Hello, my name is Bert Haskell, and I'm here to talk to you today about trends in energy. As CIOs and CTOs of electric utilities, you know that your industry is transforming itself very quickly right now. And today I'd like to talk about some insights that I've accumulated which explain some of those trends and maybe some directions that you can take to address them. The first concept I want to talk about is that of distributed architecture. The move toward distributed architecture is impacting many industries, but the energy industry perhaps is the best example of how it's really being impacted. What is happening with energy is it's becoming highly distributed. The installed base of solar energy is doubling every 2 years, as is the installed base of batteries and electric vehicles. And these penetrations or technology adoptions are what the Department of Energy calls phenomenological. And what this means is really that it's a societal phenomena, and once these technologies begin to get adopted, you get something like a Moore's Law learning curve effect, and so it's really kind of unstoppable. The trends that support, enable, and drive the demand for this technology are the desire for resiliency and the desire for off-grid, particularly in the residential sector. So this leads to a decentralization of infrastructure. It leads to a more resilient infrastructure, and it's also more empowering for individuals and for local economies because we're breaking through the sort of monopoly approach to energy supply and making it more accessible and really making energy production something that everyone can participate in. What's really important to notice, though, is that within 6 years, we're going to have 3 doubling periods. So the penetration of these technologies is absolutely exploding. And it's not only impacting the energy industry directly, but also other industries as well. The impact on electric utilities can be really divided into 2 categories: transmission utilities and distribution utilities. On the transmission side, we already know the situation is bleak. We're seeing declining demand for new transmission capacity, and we're seeing deteriorating cost recovery ability for transmission lines that go out to wind farms, for example, and for large-scale generation, such as nuclear power plants. We're also seeing coal plants get shuttered in favor of more distributed natural gas, smaller scale type of generation. So that's not going to fix itself, and in fact, that's really kind of a reality for large-scale generation. The distribution side is also very dynamic, but much more interesting. First of all, there's a move towards quality of service billing, which means that people are viewing energy as a service and not necessarily based on the quantity consumed, but simply the ability to have energy available. And that's kind of the way it should be at this point in the evolution of the industry. We're going to see current grids transformed into an amalgam of microgrids that are privately and community owned. And we're going to see a much larger service element introduced into the utility business around equipment installation, operation, and maintenance of equipment that the utility may not own. And the other thing that's having a huge impact is ever-increasing loads from electric vehicles. The opportunities are incredible for distribution utilities. As with any business area, if you're willing to embrace and disrupt your own business model before someone else does, you can really see a lot of benefit from that. One thing that the most progressive utilities are doing is making it easier for their customers to get solar and ultimately to go off grid. And so it's important to embrace this. It's also important to invest in local companies that provide these services. That helps hedge your investors when they are, through you, investing in these competitors. And then taking active steps to fragment and privatize your own operations into microgrid units and create regional service companies to support microgrid customers. These are some things that really can breathe new life into a utility business model. Developing IoT solutions for managing grid assets. Most of the large investor-owned utilities are making some investments here. Robust wireless backhauls, high reliability sensors and control relays are critical. And then one thing that we're advising, and we don't see a lot of this yet, and that is to get your artificial intelligence and machine learning capabilities developed, but then push them out to the transformer level so that they are more robust and are not dependent on long-range telecommunication links in order to keep the grid functioning optimally. Developing services to support electric vehicle adoption is important because we want to allow electric vehicles to be backup power for our customers. And we also want electric vehicles to be backup power for the grid itself. And the best way to do that is to support in-home and campus rapid charging at this point. And ultimately improve resilience, transformer level autonomy, and burying power lines. These kinds of physical architectural improvements help bring up the reliability of the grid. What are the most immediate next steps that you can deploy within your own utility? One is to understand IoT or understand customer behavior using IoT technology. So that means pulling in your smart meter data and any smart thermostat data you have, and doing some really significant data analytics. And most utilities just aren't doing a really good job of this right now. And this is an area where it's great to bring in new engineers and new data analysts and really turn them loose on this, because they're the ones that are going to inherit this new environment. And this is the best way for them to begin to understand where your customers are headed. Special energy monitors and IoT sensors can be deployed. This is really an inexpensive way to get a lot of data now, and you'll find a lot of customers that are willing to participate in that. And then integrating your data visualization of these customer data sources with your own SCADA systems is critical. Exploring grid integration of small-scale energy generation and storage. That's important to do on the permitting side. Make it easier for residential and commercial customers to adopt those technologies and connect it to your grid. And then finally, again, embracing electric vehicle charging, focusing on enabling residential charging as opposed to public charging, which is where many utilities have initially placed their emphasis. Residential charging is where the action really is on this, and that's what's driving adoption, not availability of public charging. People like electric vehicles because they can charge them at home. And enabling them fast charging infrastructure is important, and it increases the overall capacity of your grid, so it's great for system reliability as well. So that is a quick overview of the trends that I see in the industry, and I'll take any questions. Thank you.